Hi friends, let us learn about how to transform graphs. We have three different types of transformation. One is shifting either horizontally or vertically, shifting of graphs. Another is stretching of graphs, whether it is horizontal stretching, horizontal compression, or vertical stretching or vertical compression. That is stretching and compression of graphs. The third is about reflection of graphs, either reflect with respect to y-axis or with respect to x-axis. These are the three types of transformations. Let us look one by one. Easiest of them is shifting graphs, whether horizontal or vertical. Let us take one random example. Y equal to x square. We know this graph, right? Y equal to x square. It's a parabola. For example, this is a blue line in this graph. Right? Y equal to x square. Now, we want to shift this up or down. X square plus 1 is shifting this graph 1 unit up. Y equal to x square plus 2 is shifting this graph 2 units up. Similarly, if it is x square minus 2, then that means shifting this graph, the same graph, shifting it down by 2 units. This is shifting of graphs. Whatever, y equal to f of x plus some constant c. If that c is positive, then the shifting is upwards. If the c is negative, that means the shifting is downwards. What exactly we are doing? We are calculating the same x square and then plus 1 everywhere. X square, we are adding 1 everywhere. Right? What is y is equal to x square plus 1? What does that mean? Y equal to x square plus 1 everywhere. To this point also we are adding 1. To this point also we are adding 1. To this point also we are adding 1. Everywhere we are adding 1 point. Similarly, x square minus 2. Every point from this graph, we are subtracting 2 units. So 0 becomes minus 2. This 1 becomes minus 1. Likewise. Likewise, every point will be subtracted. So this is shifting of graph. Y equal to f of x plus c or minus c, then the graph will shift with respect to y-axis upwards or downwards. This is vertical shifting. Similarly, horizontal shifting. Let us take the same graph again. Y equal to x square. Let us take this graph again. Y equal to x square. X square. Now, shifting it to the right side. If you do x minus 2 whole square instead of x square, if you replace x with x minus 2, then what will happen? This graph, this one, shift 2 units to the right side. See, every point will shift towards right side by 2 units. This becomes this one, this one, this becomes this one. So every point will shift to 2 units. That is when you replace x with x minus 2. Similarly, this is f of x versus f of x minus 2. Similarly, if you replace x with x plus something, then the graph shifts towards the left side. So, for example, this point 0, 0 will shift to minus 3. This point will shift to here. This point will shift here. This point will shift here. All this entire graph will shift towards the left side if we replace x with x plus 3. So, we have just understood shifting of graphs with upwards and shifting of the graph downwards and shifting of graph left side and right side. What is the summary? The summary is like this. Y equal to f of x or plus some constant. F of x plus k, some constant. If the k is positive, that means in this case, if the k is positive, it will shift upwards. Shift the graph upwards by k units. K is positive means f of x plus 1, it will shift upwards. Similarly, if k is negative, then it will shift down again mod k units. If it is negative, for example, k is negative, minus 2, right? F of x minus 2. Then the graph will shift 2 units down, 2 units down. Similarly, if you replace x replace x with x plus h. For example, x is replaced with x plus 3. Then the graph will shift 3 units to the left. Graph will shift left h units if we replace x plus h. Now, if the h is negative, that means h is, let's say, minus 2. That means x square is replaced with x is replaced with x minus 2. Then the graph will shift towards the right. Very simple. If x is replaced by x minus something, then the shift will be towards right. If x is replaced by x plus something, then shift is towards left. And for the given equation, if we are adding or subtracting some constant, f of x plus constant, then if the constant is positive, then it is vertical shift. If the constant is negative, it is it is downward shift. So we have covered what is horizontal shift, what is vertical shift. Okay. Now, what is horizontal compression or stretch, and what is vertical compression or stretch? Let us take one more example. Okay. Let us take this example. Y equal to under root x. Y equal to under root x. This is the graph. Now, we want to stretch this. Then we multiply this equation with something, some number. For example, y equal to 3 root x. What does that mean? Whatever root x, whichever value. For example, for 1, it is 1. Right, root x is 1. You are multiplying with this with 3. So this becomes 3. 3 root x means multiply all of these numbers with 3. So that means it's a stretching, it is equal to stretching the graph. Stretching the graph, stretching in y-axis. Right, this is stretching the graph, stretching towards upwards. That is stretching the graph if you multiply given function with some constant. Right, then constant which is greater than 1. Now, if this constant is lesser than 1, then what will happen? This is equal to compressing the graph. For example, if it becomes 0, then everything will become 0. Right. If it is 1, the constant is 1, then the graph is as is. Y equal to root x is equal to y equal to 1 into root x. Similarly, 2 root x will be somewhere here. 3 root x is somewhere like this. 4 root x is somewhere even bigger. Even bigger stretch. Right. 100 root x is much, much bigger stretch. Right. When you are multiplying the function with some constant, that means you are stretching if the constant is greater than 1. You are compressing if the constant is lesser than 1. This is stretch and compress in terms of y-axis. This is function into some constant. Now similarly, let's take another case. Y is equal to root x. Here we are replacing x with 3x. F of x versus f of cx. Right. Now that c is greater than 0 or greater than 1 or less than 1. X we are replacing with some constant into x. Here we are multiplying the function. Here x we are replacing with some constant into x. Now what will happen? If root x is replacing with 3x, x is replaced with 3x. What does that mean? That means the graph will get compressed towards the left. So this is compression across horizontally, compression across horizontally. So for example, what does that mean? Here, y equal to root x. At 1, it is 1. Right, at 1, it is actually 1. But in case of 3, y equal to root 3x, y will be 1 when it was 0.33 only. Right, 3 into 0.33 equals to 1. So y will be 1 at this point itself. So that is 3 times compression. Right, here 1, it is y equal to 1 at this point. But in the yellow graph, y equal to 1 when x is 0.33 only. So that means this entire graph is compressed 3 times. Right. This is compressed 3 times. Similarly, stretching. In this case, the pink graph is stretched 3 times because the constant is 1 by 3. Right. This is compression and stretching of the graphs. Now, there is one more case. Y equal to root x. Right. If you multiply this root x with minus 1, that is y equal to minus root x. Whatever is all this positive will become negative. This exact mirror image with respect to x-axis. Y equal to minus root x. If it is 1, it becomes minus 1. If it is 4, it will becomes minus 4. If it is 9, it becomes minus 9. Right. So this is exact reverse or exact mirror image across x-axis. This is reverse of this. This is a reflection around x-axis. That is when f of x versus minus of f of x. Similarly, f of x versus f of minus x. that is a reflection around y-axis, right? So for example, what root 1 is 1. Now, when if you take root of minus x, that means if you put x as minus 1, then also y will become 1, right? So if root of minus x is a reflection of y-axis of root of x, right? So essentially what we are saying is, it is very simple. We given a function, if you multiply this function with some constant c, if the c is greater than 1, that means in this case c is greater than 1, then it is stretching the graph vertically by that factor. This is stretching the graph by 3 factor of 3 units. Similarly, 1 by c into root x. If that c is greater than 1, that means 1 by c will be less than 1. Right. Then it is compressing by a factor of c. That is this graph. Similarly, y equal to f of cx. Y equal to f of cx. Here multiplication of constant into f of x. Here f of cx. F of cx means it is compressing the graph horizontally by factor of 3 units, by factor of c units. In this case, see, f of x is root x, f of 3x is root 3x. Right. Now f of x by c, if the c is greater than 1 again, then that means x by root 3, this is actually stretching the graph in horizontal way by a factor of again c. Now again, for c equal to minus 1 or for c equal to minus 1, c equal to minus 1, f of minus x. F of minus x is reflection of graph across the y-axis, root x versus root of minus x. Similarly, minus of f of x is a reflection around x-axis. Hope you understood all of this. Now let us do some examples to understand this in detail. For example, how do you draw this graph? Y equal to root of x plus 4. Right. We know what is y equal to root x. How does it look? Y equal to root x. It will look something like this. Now, root of x plus 4. Root of x plus 4 means what? So, this is f root of x plus 4. F of x plus 4. Right. F of x plus 4. X plus 4. Earlier we have discussed f of x plus 4 is shift to left side. For example, this is f of x and f of x plus 3. F of x plus 3 means shifting left. F of x minus 2 means shifting right. Right. So we start with f of x. F of x is root x. Root x. We start with root x. Root x. And then f of x is root x. F of x plus 4 is root of x plus 4. Right. So f of root x is something like this. This is root x and root of x plus 4. This is f of x plus 4 is shifting this graph 4 units to the left. So that's why this is the graph. Right. Similarly, 9 minus x. Root of 9 minus x. What does that mean? What is root x? Root x will look something like this. Right. This is root x. And minus root x. How does it look? Minus root x will look, this is, sorry, root of minus x. Root of minus x, how does it look? This is root of minus x. Right, we just discussed. Root of minus x, f of minus x. F of minus x is reflection about y-axis. Right, root of minus x. Root of minus x will look something like this. Now, what is 9 f of x? Let's say f of x is equal to root of minus x. Then, what is 9 minus x? 9 minus x is f of x minus 9 equal to root of x minus 9. Right. This is equal to 9 minus x. Right. If f of x is minus root x, that is this graph. That is this graph. Right. F of x is minus root x, which is this graph. Then f of x minus 9 is what? Minus of x should be replaced by x minus 9. Right, minus of x minus 9, which is equal to root of 9 minus x. So root of 9 minus x is nothing but f of x minus 9 when f of x is root of minus x. So basically this root of minus x, this graph we have to take, and then x minus 9. That means it is horizontal shift 9 units towards right. Right. So now this graph will be shifted 9 units towards right side. Towards right side. Right. Then this becomes f of that becomes y equal to root of 9 minus x. Right. So now this one. Let us look at this one. Y equal to first y equal to mod x. What is that graph? Y equal to mod x, we know it looks something like this. Right. Y equal to mod x. F of x is mod x. F of x minus 2 is what? Mod of x minus 2. Right. Now f of x minus 2 means what? This graph should be shifted 2 units towards the right side. So that is this graph. Right. Now similarly, this one. 1 minus x minus 1. Mod of 1 minus x minus 1. Let's start with y equal to mod x. Y equal to mod x is this. Y equal to mod x is this. Right. Now y equal to mod x. What is y equal to mod of minus x? Mod of minus x is a reflection around y-axis. Right. So obviously this graph is like this. Even if you reflect, you will get the same graph. Right. The reflection of this, you will get the same graph. So y equal to mod x, y equal to mod of minus x, both graphs are same. Now let's say 1 minus x, mod of 1 minus x. How do we write this? Then we can write if f of x is mod of minus x, f of x minus 1 equals mod of minus of x minus 1. This is equal to mod of 1 minus x. Right. F of x minus 1 is mod of 1 minus x. Right. So mod of 1 minus x will be what? This graph shifted 1 unit towards the right side. Right. That is this one. So if mod x is this is mod x, then this is mod 1 minus x. Shifting 1 unit towards right side. This is mod 1 minus x. Right. Now let's say g of x is mod 1 minus x. Now what we are doing? G of x minus 2. G of x, sorry, minus 1. What does that mean? This entire graph will shift 1 unit downwards. That is 1 unit downwards. G of x minus 1 means shifting 1 unit downwards, which is a vertical shift. So what is the final graph of mod of 1 minus x minus 1? That is this graph. We started with mod of x. This is mod of x. Then we inverted this mod of minus x. Mod of minus x is also same. Then mod of 1 minus x. Mod of 1 minus x is f of x minus 1 when f of x is mod of minus x. That's why this graph is shifted rightwards, and then shifted downwards. Right. Let's take one more example. 1 plus root of x minus 1. What is root x? Let's start with root x. Root x is something like this. This is root x. Let me draw with a different color. This is root x, right? This is root x. Now what we want? Root of f of x equal to root x. Now root of x minus 1. What does that mean? F of x minus 1 is root of x minus 1. That means root of x minus would be something like this, shifting rightwards. Root of x minus 1. That is this one. Now, if g of x is root of x minus 1, now g of x plus constant will be this graph shifted upwards. right, by 1 unit. G of x is root of x minus 1. Then what is y? Y equals 1 plus gx, right? 1 plus root of x minus 1, 1 plus gx. That means, this graph will be shifted 1 unit upwards. So that is our final graph, y equal to 1 plus root of x minus 1, right? Similarly, what is 1 minus root x? What is root x? Root x is something like this. This is root x. What is minus root x? Minus root x is the same graph shifted the same graph which is a mirror image or reflected over x-axis, right? Minus of root x. That is this graph. Now, what is 1 minus root x? 1 minus root x is nothing but minus of root x plus 1. If g of x equals minus root x, g of x plus 1 is 1 minus root x, right? Minus root x plus 1 is equal to 1 minus root x. So that means what? This graph should be shifted 1 unit upwards. So that's why this is the final graph, 1 minus root x. Right? Very simple. Next one. Let's take one more example. X plus 1 whole power 2 by 3. Okay. For this, first let us understand what is x power 2 by 3. What is x power 2 by 3? X power 2 by 3 is x power around 0.66666, something like this. Right? We know x power 0.5. What is x power 0.5? X power 0.5 is root x. Right? X power 0.5 we know. What is x power 0.6666? How does it look? X power 0.66 is something like x cube root of x whole square. Right? X power 2 by 3 is cube root of x whole square. Right? Now cube root of x can be negative also. But whole square is always positive. That means this graph is always positive. Cube root of x when x is less than 0. Cube root of x when x is less than 0. Cube root of x will be less than 0. Right. But cube root of x whole square will always be greater than 0. Okay. Now let us understand how does this graphs look. For example, let me show you. This is y equal to x. Y equal to x is what? A simple straight line. Y equal to x is a simple straight line. Now let us try to draw y equal to x power 0.25, y equal to x power 0.3333, x power 0.5, x power 0.6666, something like this. Okay, in the increasing order, x power 0.25, 0.3, 0.5, 0.6666. Okay, now this is y equal to x and y equal to x. Okay, the lowest one that you are seeing, this one. This one, this is 0.25, x power 0.25. That means x power 1 by 4. Right. Then x power 0.33. Then root x. That means x power 0.5. This is x power 1 by 3. Then x power 2 by 3. This is 2 by 3. And this is y equal to x. Right. If you see this one, y equal to root x. Y equal to root x, this green line, this thick green line. There will not be any negative part in this graph because root x is always positive, is always greater than 0, greater than or equal to 0. Root x cannot be negative. So this thick green one, this is always positive. Right. This one, this graph is always positive. Right. Now light green one. Light green one is x power 2 by 3. Like we just discussed, x power 2 by 3 means this will always be positive or at max 0 because it is a square of x power 1 by 3, cube root of x whole power square. So that's why if cube root of x, what is cube root of x? X power 1 by 3. X power 1 by 3 is this red one. this one. This red one, x power 1 by 3, it can become negative. Right, this graph, if you see, it can become negative. As when x is less than 0, it can become negative. Right, it can become negative. That is x power 1 by 3. And x power 2 by 3 is this light green graph. X power 2 by 3 is this light green. And y equal to x is this straight line. Y equal to root x is this one. If you notice, if you notice, when x is greater than 1, when x is greater than 1, let's say x is greater than 1. Okay, then if you notice x power 0.25, x power 0.35, so when x is greater than 1, higher the power is higher, then the value would be higher, right? So x power 1 versus x power 0.6, x power 1, when x is greater than 1, this will be x power 1 is greater than this one, greater than this one, greater than this one, greater than this one, right? When x is greater than 1, right? When x is greater than 1, whereas when the power is higher, the value would be higher, right? So that's why when x is greater than 1, so the graphs towards the right side of this one, y equal to x would be highest, then x power 2 by 3, then x power half, x power 0.6, x power 0.5, x power 0.3, x power 0.2, something like this. The same thing is reverse when x is below 1, right? When x is below 1, then the lower power is higher, right? For example, x power 0.25, this is highest. When x is below 1, this x power 0.25 is greater than, x power 0.33 is greater than, x power 0.5 is greater than, x power 0.66 is greater than x power 1. Please notice the difference. 1 is the point at which this changes. When x is greater than 1, higher the power, the value would be higher. When x is lesser than 1, lower the power, the value is higher. Right. So, for example, when x is less than 1, x power 0 would be equal to 1. Right. So, now taking this, now we just realize what is x power 2 by 3. X power 2 by 3 is some graph which is like this light green graph. Right. Now, let's go back. We know what is x power 2 by 3 graph. X power 2 by 3 would look like something like this. Okay. Now, that is f of x equals x power 2 by 3. Now, f of x plus 1. X plus 1 is x plus 1 whole power 2 by 3. What is f of x plus 1? F of x is some graph. Then f of x plus 1 is the graph same shifted 1 unit towards the left. So, this one shift 1 unit towards the left. So, this is our required graph. Similarly, this one, x power 2 by 3. We know what is x power 2 by 3. F of x is x power 2 by 3. What is f of x minus 8? This is x minus 8 whole power 2 by 3. That means the same graph, this graph is shifted 8 units towards the right. So that's why this 0 has become 8. So f of x minus 8 whole power 2 by 3 is this one. Right. Hope you guys understood this. Next one. Now, x power 2 by 3. What is x power 2 by 3? It looks something like this. We just discussed. X power 2 by 3. Now, f of x is this. Then f of minus x. Or sorry, minus of f of x. Not f of minus x. Minus of f of x. Minus of f of x. Equal to minus of x power 2 by 3. Right. That is a mirror image with respect to x-axis. Minus of x power 2 by 3. This is x power 2 by 3 minus of x power 2 by 3 is this graph. Let's say this is g of x. G of x is minus of g of x is minus of x power 2 by 3. Okay. Now g of x plus 1. What will this become? Minus x power 2 by 3 plus 1, which is nothing but 1 minus x power 2 by 3. G of x plus 1 is this graph, whatever this graph is actually shifted 1 unit upwards. That is this graph. So y equal to 1 minus x power 2 by 3 is this graph. Similarly, y plus 4 equals x power 2 by 3. What is x power 2 by 3? It is something like this. Right? Agreed. Now, what is y? Y equals x power 2 by 3 minus 4. What does that mean? This entire graph minus 4 means it should do a vertical shift downwards 4 units. So that means the graph will become this. So y plus 4 equals x power 2 by 3 means y equals x power 2 by 3 minus 4. This is the graph. Right, guys? Now we have done some good examples of how to shift graphs or how to transform graphs, how to compress graphs. Okay, the summary is when you are doing a vertical shift, then given function with plus some constant, plus or minus constant. If it is plus, plus means upwards, minus means downwards. Okay, those many units if it is a vertical shift. Similarly, horizontal shift, plus means leftwards, minus means rightwards. Okay, we have to replace x with x plus something or x minus something. This is horizontal shift. Similarly, stretching, if the constant, okay, if the constant into function, if the constant is greater than 0, then it is upward stretch. Or if this constant, this multiplied that you are multiplying is lesser than 1, that means it is compression across y-axis, some compression vertically, right? Similarly, f of x is replaced by f of some cx, right? Then it is compression horizontally, and if the c is lesser than 1, then it is stretching horizontally, right? And y equal to root x or any function minus of f of x is is a reflection around x-axis. Minus of f of x is reflection around x-axis, and f of minus x is a reflection around y-axis. Right, guys? Hope you understood this. Thank you. Very simple. Hope you like this.